Good morning, everyone. You all seem fairly awake, which is quite staggering for a Monday morning. I'm only just coming round from the first coffee. I'm going to be talking about Puppet and Vagrant. Some of you may be using these tools in your environments already. That's cool. You can sit back and relax. Maybe check the careers page on our website. We are hiring. I think maybe these days we have to title things a bit like this to get everyone's attention. Two cool technologies that will actually change your life. It's a bit of hyperbole in there, but actually I think Puppet and Vagrant have really sort of transformed the way I've worked over the years. I've been doing sysadmin, I suppose, for quite a long time. Back in the old days, we were doing all this stuff with hardware, and then we got virtualization to play with. I've only been using Puppet now for 6 years. Compared to the length of how long I've been doing this, it's quite a short amount of time, but I guess compared to some adopters of Puppet, that's quite a while. We've seen it change quite a lot. I think I started using Puppet before classes and modules were introduced, which was a bit of a stretch at the time. And Vagrant we've been using since about 2011, which is when it became properly usable. So those of you who are systems administrators or developers are probably kind of familiar with this loop, this sort of feedback loop. And for those of you who don't know what a sysadmin is, it's what we used to call DevOps engineers before we stopped giving people names to match their job title, what they're actually doing. This loop is quite familiar to most people who've worked in software and systems, in that there's a thing that you want to change. You're going to set up some kind of test environment. If you're lucky, you might be doing this on production, as we probably did back in the old days. You're going to make a change. You're going to see whether that works or not, and if it didn't, you're going to keep sort of looping around until it does work, and then you're going to commit it to your version control and carry on from there. And really, because your life is stuck in this loop, the trick really is speeding that loop up and improving your cycle time and getting all this stuff done faster. And that's really, I think, what the new tool chain is letting us do. As Gary says, it's about changing more stuff more quickly and more reliably, and these tools are letting us do that. So back in the old days when we were doing this kind of thing, we do this in hardware, and I vividly remember having to get up from my desk and walk across an office to a server cupboard, punch in the code, get in there, plug in the keyboard and monitor if someone else was doing the same sort of thing, reboot the machine, which would take a couple of minutes to come up when it's checking its RAID arrays and all that kind of jazz, kickstart from the network, sit and wait for it to do that for about 30 minutes, because of course we were on crappy old IDE disks back then. Once that kickstart's completed, we're going to upload the script that you're working on, in this case probably Bash. I think back then we were doing some things in Perl as well. I do not miss those days one bit. And then you run those scripts to see what they did, and that takes sort of 15 minutes or so, because again, old hardware, slow network connections. And then you see whether or not it worked. And if it didn't work, maybe you tweak the scripts a little bit. You have to try and remember to copy the changes that you've just made in those bash scripts back onto your workstation, so you don't lose them next time you power cycle the machine. The whole thing was just nightmarishly slow. Kind of good for the waistline, because you're getting quite a lot of exercise up and down across the office. Quite good for your consumption of things like Reddit, probably Slashdot back then actually, which you'd be able to spend 30 minutes browsing in between kickstarts. But it wasn't a productive environment. We believed in automation. We believed in doing this stuff repeatedly, but the tooling to let us test all this stuff was pretty immature. So following that, when VMware became more widely available, I think I started using it when they made VMware Workstation available for Linux. You shorten this loop a little bit, so you take the kickstart and do it once, then snapshot the machine, and then your loop is basically roll back to the VM snapshot, upload your bash scripts, run those. Again, that'll take about 15 minutes, see whether it works, and then move on. So it's still kind of slow, because this is old days hardware, but faster than the actual hardware version. Less good on the waistline, because you can do all this at your desk now. I've just been spreading out gradually since those days, really. But there are still ways in which it would have been nice for this to be quicker. So somebody solved those. Mitchell Hashimoto released Vagrant a handful of years ago. to make all this a bit more streamlined. So Vagrant, if you're unfamiliar with it, it's a command line tool that wraps around existing hypervisor setups. It runs on Linux, Mac and Windows. They've put a lot of effort into supporting all platforms, so it doesn't really matter what your host operating system of choice is on your workstation. There's still plenty of good stuff on all of those. FreeBSD it works on as well. I've got a colleague who got this up and running on FreeBSD. I don't necessarily recommend using that on your desktop. It currently supports out of the box VirtualBox and on Windows it supports Hyper-V. You can also buy a module that supports VMware Fusion or VMware Workstation. And the things it adds to the existing hypervisor is a straightforward command line tool for starting, stopping, otherwise accessing the virtual machines, and a configuration language for letting you describe how your virtual machine should be set up. It'll permit folder sharing, so that the folder on your workstation that you're doing your code in can be exposed into the guest really easily. And because it runs on your laptop, it's as portable as your laptop, so you can pick it up and take it home if your boss hates you and would rather you were working on the weekends rather than enjoying yourself. So Vagrant, as well as all of that, provides an ecosystem for managing base boxes, so a sort of template management system, if you like, for presenting an operating system with a couple of tweaks to allow Vagrant to talk to it. So there's an insecure public key, private key pair on an SSH account called Vagrant. All the passwords are Vagrant. It's not something that you're going to put in production, but you're going to have it running on your workstation. And all those changes facilitate ease of use from the command line. There's a new thing called Vagrant Cloud where all this stuff is available. You can choose lots of different base boxes. We publish a handful. There are Puppet Labs use it, as you'll see when I get onto the live demo, which I'm dreading because live demos never work and it's a Monday. You describe the box configuration in this sort of text format. I'll show you an example of that in a second. And then you can share both of those with the rest of your colleagues, so everyone can work in the same environment, whether they're Windows users, Mac users, Linux users, whatever. So your command line tools are then Vagrant up to start a new environment and get going. Vagrant destroy, throw it away. Vagrant SSH to connect into it and use it. It's all nice and straightforward. And the best way to describe or to show the benefit of this is graphically. And if you're a web developer, for example, you're in a sort of pre-Vagrant world, what you might be doing is running an Apache and a MySQL and all your kind of your other components on your laptop. So you'll have downloaded, if you're a Mac user, you'll have whatever MySQL has come out of Homebrew and whatever version of PHP has come out of Homebrew. You're running your Messenger and you're listening to Spotify and you've got your tweets going on there. So you've got this sort of, you've cluttered your workstation with all this sort of development stuff. And the versions that you're using are probably not going to match what's in production because your systems team are probably not going to deploy the version that you've got on your Mac into live. So what Vagrant does is it takes the things that are part of the system on the test and allows you to enclose them in a virtual machine of its own with this sort of shared file system layer in between. So you never have to copy anything into the virtual machine. All of your local text editing tooling is available to you. All of your version control tooling is available to you if you're a sort of an IDE user or something else. You can still use all of those, but you can run the code inside this Vagrant environment. But this is a Puppet event, so we should probably stop talking about Vagrant and talk a little bit about Puppet. I'm going to cover this quite briefly because obviously Gary sort of covered this this morning. Puppet's a configuration management tool, and I'm assuming everybody was aware of that. Primarily, the appeal for this, for me, really was that it's an infrastructure as code tool. So it allows you to describe what your infrastructure, or you desire your infrastructure to look like, in text files as though it was software. And because you're doing that as though it was software, you then have access to all the tools that the software developers have had for years, so version control and IDEs and refactoring tools and syntax highlighting and all that sort of kind of good stuff. It's also convergent, and the convergency of Puppet is for me one of the most important things. every time you run Puppet, it'll move the state of the system as it currently is in the direction of the state that you desire. And so on a subsequent run, if you run Puppet twice, as long as you've written your manifest in a sensible way, the second run won't change anything. And the important thing is that you're describing to Puppet what the system should look like, not necessarily how it should get there. That's, I guess, not entirely true if you're writing types and providers, but for the most part, if you're writing Puppet DSL, you're saying, I would like there to be a thing that looks like this. I would like there to be another thing that looks like this. And Puppet will move the state in that direction. So I'm going to briefly kind of talk over a sort of demo project. It's a demo project that I've got on GitHub that you can download and play with. I'm going to walk you through it, and I'm going to actually show you that feedback loop in action and how Vagrant helps us through that. So this is the structure of the project. This is a standard file system layout. This is what I check into Git. There's a README documentation, which is novel, I think. There's a Vagrant file, which is the way that we configure Vagrant. It's how we describe what our virtual machine is supposed to look like. I've got an application folder here, which is not Puppet specific. It's just a couple of PHP scripts that I'm using to demonstrate how you'd work with an application as well as Puppet code. And this is a pattern that we use with a lot of our customers. We'll provide them with a way of versioning their Puppet manifests alongside their application, so that developers can check out the whole thing, bring up a dev environment that's been configured with Puppet, and then their application is, in theory, going to work in that world. Then underneath Puppet, we've got a single manifest file, site.pp. That's going to be the entry point, which you may be familiar with if you're a Puppet user already. And then there's a modules folder that contains a number of modules that like namespace under the demo namespace, which is going to configure Apache, it's going to configure some other defaults, it's going to configure PHP. Then I've got some other modules that don't quite fit on that screen. So the Vagrant file looks like this. Hopefully you can read that. Vagrant is configured using essentially Ruby, so you can do anything Ruby style in there. You can move environment variables around and check for things on the file system. What you can't see here is some other magic that I've got to make sure that because I'm on a machine without an external network, that if I've got a local mirror, it's going to use that for packages. Things of note here, the box configuration at the top there, that's using the Vagrant Cloud nomenclature for identifying a specific Vagrant box that in the old days used to have to give a URL and some other stuff. This says I would like the Puppet Labs CentOS 6.5 box that has a Puppet in it, and then Vagrant can version that, so it can tell you if there's a new version available as and when the guys who build these at Puppet Labs update them. This here is a batch of facts. The facts are basically stored in a key value hash. You can see that I've set a fact to say Vagrant equals 1. So once we start running Puppet inside this box, there's a fact that lets me know that we are in a Vagrant environment, so I can do things on a conditional basis, based on the fact that I am in the Vagrant environment. Then there's a fact called roles, which contains a list of role names. And the roles and profiles pattern, if you like, is a fairly common way of laying out modules. We'll go through how that sort of fits together as I demo. Down here, the provisioner. Vagrant supports a number of provisioners, Puppet's just one of them. There's some magic behind Vagrant scenes that knows how to deal with Puppet inside the VM, so it knows how to connect to the VM and run Puppet using the arguments that we've given it. But ultimately what we're doing here is passing the facts that we've defined earlier on, and we're also giving it a manifest path, a module path, and a manifest file, which, if you recall, match the shape of the layout here. So we're saying manifest site.pp, Puppet modules, and go from there. So next up is site.pp. Site.pp is doing, this is where we define what the node is going to be configured as, and the roles and profiles approach requires that we have just a single role, a single node called default. If you're kind of new to Puppet, you've probably used node to match host names or host name patterns or what have you. The approach that we use here is to say host names don't matter. We don't want to have to be editing this file every time we add a new machine. We are completely host name agnostic at this point. So the default node is always going to be hit by anything that runs the site.pp in this set manifest. The first thing we do is apply some defaults out of a class called demo defaults, which was in the modules folder. And then we do this thing where we check to see whether the roles fact, which if you recall we've exposed to Puppet by putting it in the Vagrant file, Vagrant's passing those roles or those facts into the Puppet run. We're checking to see whether the web server role is set in that list of roles, and if it is, we're going to put a little notice up to say that we found that role, and then we're going to dispatch to the web server role class. So you can picture it in a world where the same manifests are used to deploy a production environment, that we get facts onto our production machines in one way or another. We tend to, if we're using AWS, for example, we use the user data script when the machine starts up to write the facts of the type of node that it is into the facts directory, so that when Puppet runs, it can find out that it's a web server or a database server or whatever. In the case of the Vagrant test environment, we're composing both of the roles together. We say both of these run on the same machine. So it's important for us to make sure that the roles that we define can coexist together, so we don't have port clashes or resource clashes. And in a way that improves the way that we write this manifest. So moving on from that, we can have a look at the defaults class. And this is an example of how we're using the am I running Vagrant fact in these manifests. So if you put this onto a production infrastructure where there isn't a Vagrant fact set, then we won't do these things. But in our test environment, we're just going to stop the firewall, because there's no point us running firewall on a machine that is connected locally that we're testing against. We are going to demo some things. Cross your fingers, let's see how this goes. I'm going to go into mirror mode so I can see what I'm doing. Okay, everybody read that? So you can see this was the file layout. There we go. File layout that I showed you before. Nothing's changed. No smoke and mirrors here. There's a little bit more complexity in the Vagrant file than I showed you previously. This Vagrant file will support both the VirtualBox and the VMware Fusion providers. We set up a private network, so when the Vagrant box comes up, this IP address will come up with it and will only be visible to your workstation. So you don't have to worry about those being accessible to the outside world, or otherwise compatible by your colleagues if they're that way inclined. There's the facts there, and then I've got my bit of magic there to make sure that I've got a local mirror that I can use. See, it's just regular Ruby. If you're not familiar with Ruby, it's not that important. I found that I've learned a lot of Ruby by doing things with Vagrant and Puppet. And there's the provisioner. So we can do Vagrant up. And this is going to clone the base box that I already have on my workstation. If you didn't have that there already, it would pull it down from the network. It checks to see if there's a new version available, which has warned out here because I'm not connected to a network. But if there is a new version available, you'll be told and informed how you can update that. This is the VMware Fusion provider. I find it's more performant and a bit less collapsible than VirtualBox, so the VirtualBox has got better in recent years. So first of all, what we do is we check that the network devices work. We do some port forwarding, so Vagrant on the client that we're running here can talk to things on the inside of the box. There's a bunch of setup involving mounting folders, and then as soon as all of that's done, we start running Puppet. So Puppet is now going, and you can see from here that we found the roles that we set up in the Vagrant file, and then we've gone ahead and configured Yum, we've configured PHP, we've configured Apache, we've configured the database role. So now we can go to my test web. Wherever I left that. There we go. So this is that's the IP address that I set up for this Vagrant box to use. And this is a PHP info script that's run from the application folder out of the shared NFS shared folder inside the Vagrant box. We can also go to ping.php, and we can see that MySQL is, so this is failing because there's no MySQL connect function. That's all fine, it's what I was expecting. We can, the reason why that is the case is because I haven't configured, asked Puppet to install the package for the MySQL support in PHP. For those of you unfamiliar with the syntax here, the class definition should be reasonably obvious. Use of this resource name package with a capital P at the beginning of it sets defaults within this scope. And so when the package is installed, or so when the package is instantiated, the defaults apply this ensure install to it. So we're saying install the package. And we also have this notify that says once that package has been installed, we need to tell the web server that that is the case. So having made that change, we can do Vagrant provision, which will rerun the provisioner inside the running Vagrant box. And off we go. So you see that on that run, the current state of the machine is that there's no PHP MySQL package installed. The desired state of the machine is there should be a PHP MySQL package installed. And so Puppet's gone ahead and installed that package. It's also triggered a refresh against the HTTPD service because that's what we requested when we configured that package install. So if I run Vagrant provision again, and again this is invoking Puppet inside the box, then you see it makes no changes. It's still flagging the web server and database role finding because that's just an instructional warning or an info log level event, but it hasn't actually made changes to any of the resources on the machine, which is exactly what we'd expect. So we can go back to here, go, oh, MySQL is actually still not running, but we have a different error. So actually, is MySQL running? We can SSH into the machine. We can see whether or not MySQL the service is running. It's not. Is that because it's not installed? It's not that because we've got the MySQL server package installed already. So it seems that the service hasn't started properly. So if we have a look at the implementation of the role database module, you see that we've requested that the server be installed, but I haven't got anything there to start it. And so we can say service, if I can remember how to type, sure, running. I'm going to put a chain in there so that there's a dependency between the service running and the package being installed. Then I'm going to run Vagrant provision again, which blows up because I've called the service the wrong thing. You see your feedback is instant, the amount of time it takes to run is short. It all pops out in the same place. But actually the service is called MySQLD. Run the provisioner again. From stopped to running. MySQL running, yes. So that's your kind of workflow when we're talking about doing this sort of thing. Back to the slides. Okay, so the benefits of doing things this way. You can see that there's a short cycle time. So the amount of time it takes to make a change and to see the results of that change, very, very short. And in fact, you can, having made those changes and seen them work that way, you could also do a vagrant destroy and a vagrant up and start again completely from scratch, so that you know that what you've written is going to apply completely to a clean box. One other technique that we use for making sort of sizable changes to things that are also in production would be to check out the Puppet repository at a known Git revision and vagrant up from there. So we take the server up to what we thought was the version previously, and then to change the Git tag so that we're running on the latest version of what we are thinking that we'd like to change, and to run that against the box that is in the old state. So rather than testing everything from fresh every time, in which you can usually be fairly certain that that's going to work, it's rare that we do that every time on deployment of infrastructure, particularly not infrastructure that has stakes like database servers or Redis servers or what have you. And so it's possible to test that delta rather than a from scratch to current. Benefit, there's no copying of files. I didn't have to, having made my change to those manifests, I didn't then have to synchronize them to the box or anything like that. That's broadly true of all the providers. Actually, with Vagrant, you can target things like AWS and vSphere instances that are off your machine. And in that case, Vagrant itself will rsync those changes up. I believe it can also watch for changes locally and sync them when they change. So there's copying of files around, but you're not having to do it yourself. In this local mode, I could log into the virtual machine, make changes to the config files in there if I wanted to, and they would still be reflected onto my workstation, still version them with Git and what have you. So the workflow is really, really tight. We can obviously share this box and the manifest with development teams or other people on the systems team. So new customers that we work with will show up with our Puppet manifest. We'll provide them into a Git repo, add the customer's application repos to the same configuration, and then they're up and running. And they're up and running on versions of infrastructure components that we will deploy in production. They no longer have to spend time themselves keeping their version of Ruby or their version of MySQL, PHP, what have you, up to date. In a large team, that's a real boon. Particularly if you've got a complicated infrastructure. I've worked on large Drupal projects where there was a requirement for Apache, PHP, MySQL, Redis, Memcache, Solr, some other stuff. So having all of this config in Puppet, in a Vagrant box, means that the 20-person development team doesn't have to spend huge amounts of time figuring out how to install, compile, configure these components. They can just download Vagrant, download the Vagrant box, check out the source, Vagrant up, off they go. The other benefit of this kind of approach is it's really easy to try the config that you have on a different base box. So that was the CentOS 6 box. Obviously CentOS 7 is around, waiting to ruin our life with systemd. We can take a CentOS 6, take our CentOS 6 config, replace the CentOS 6 box with the CentOS 7 box, run the tests again. If those tests fail, we can then wrap bits of that config in conditionals and make it behave for CentOS 7, go back to 6, make sure we haven't broken anything, and that workflow is really important. Our manifest set is capable currently of supporting both CentOS and Ubuntu, so we're constantly sort of flicking between base boxes for figuring out whether we've broken anything in one environment or the other. There are some advanced usage you can do with this kind of tool chain. So Vagrant doesn't only support single box, you can set up multiple boxes, and those multiple boxes can all have a private network that they share. So you can test things like your clustering, your load balancing, failover techniques. You can test that pulling the plug on the machine doesn't cause your config to break. All that kind of stuff can be done locally and as portably as your laptop and as scalably as you have laptops per developers. Vagrant Cloud has a bunch of new features in it. Vagrant Share allows you to essentially port forward your ports from your Vagrant box to make them available at a known address that you can then share with other people. So if you're a developer who's working with this sort of solution, you can bring up a version of the site. You can share use Vagrant Share to get a URL for it, paste that into chat with someone who's on the other side of the world. They can see what's going on your Vagrant box. When you're done with that, you can tear that down and unpeel it again. If you're really kind of leveling up, then you can build production images and Vagrant images with the same set of tools. So we have an AWS image that closely matches our Vagrant images because we use Packer to build both of them, publish them both on both cloud and in the AWS store. So we know that the version of Puppet that we've built and all the kind of ancillary tooling that we know that we need on a system from day one, we can know that the version that we've got in a versioned Vagrant environment is the same as our versioned AWS environment. The other thing to keep with Vagrant is that you can then wrap all of this stuff in automation. So you can build automated test suites for all this stuff. We have there's a plugin for Vagrant floating around that we've written called Vagrant Cucumber, which lets us write tests for Puppet manifests and for things that run on servers in the Puppet, the Cucumber BDD language. So we can say, given I have a server called server, given I have a server called client, when I install an LDAP server on the server and I put a user in it, then it should be visible on the client, tear it down, try again a different operating system. And that sort of stuff is really valuable to us. Lets us validate that the Puppet that we're writing is, to some extent, workable. I believe Beaker will also target Vagrant as a hypervisor. Beaker is a Puppet Labs tool for writing automated tests for modules. You can try it yourself. I'm going by Dawn's comment earlier on, I wouldn't try this now because the Vagrant image is quite big, and if you're all sat pulling 500 megs down, I don't think anyone's going to be very happy. But try it from home on your DSL version if you like. The instructions are in the README, just a sort of primer on getting started with starting the Vagrant box and working with it. And if you have any issues with using that, then you can open a new GitHub issue and I will answer that for you. This is me. Scale Factory is a small consultancy doing infrastructure design, build, support, and operations. We're very big on Puppet and Vagrant. Come and have a chat with me later on if you'd like to engage us or anything. We're also hiring, and I can take any questions. We've got, what, another 10 minutes? Yep. Anybody? At the back there, sir.
How do you handle the separation of development chain, development configuration, production?
How do you reliably handle the differences between development config and production config? So the question. So we use Hiera for that. Gary touched on Hiera earlier on. In that nodeless environment, the thing that we try and do is to never put anything in the Puppet manifests that is conditional on facts such as the host name. There are one or two exceptions to that, but for the most part, we have no host name related stuff in our manifest anywhere. In our production environment, we set a bunch of facts for. In all of our environments, we have 3 facts that we set. We have roles, which you saw demonstrated there. We also have location and environment. And location might be data center 1, or it might be EU West 1, or something of that nature. And environment might be test, development, Vagrant, whatever. And so for things like, so a good example of this would be, what's the address of my database server? So in a single Vagrant box setup, the Vagrant server, the database server address will be localhost. In production, it's probably a big, long, horrible string generated by RDS. Or it might be just the word database that then DNS handles. So we have those facts and those facts look up into the Hira hierarchy values such as where's my database. So Hira lets you set a hierarchy of locations from which config will be obtained, and our hierarchy goes from hostname, which is the most specific, to location environment tuple, to location, to common. And Hira will, when you ask it to look up a value such as where is my database, that's one call in Puppet, it goes to Hira, and Hira will start at the most specific YAML file and work down until it finds a match for the key you're asking for at the most specific, in order of the hierarchy basically, so at the most specific point. And what that means for us, what it means for our customers is that when you're setting up a new environment, if you're setting up a staging environment or a production environment, there is no variance in the Puppet manifests between those environments. All the variance lives in Hira. So most of the teams we work with are Puppet literates, but not Puppet experts. We're providing that expertise to a dev team who can read and write bits of it, basically. And so to have that kind of interface between the difficult stuff where they might not like to tread and the things that they're going to change reasonably often is a clean way of making that separation. There's no demonstration of Hira in that example, but if you want a bit more detail about it, I can show you a more realistic example with some Hira stuff in it. Anyone else?
How do you handle things like, say, a checkout of your application? Do you make sure that Hira comes in somewhere in your local file system, or do you make Vagrant check it out operations?
So in that demo, I've got Puppet manifests and an application config side by side in the same Git repository, and that works reasonably well for small teams or small projects or organisations where there is only one set of infrastructure and one application to run on it. What we actually do is we create a Git repository with the Puppet manifests in it, and then we use whatever the customer already has for their application. We put them side by side in a Vagrant folder, so I have Vagrant customer name, infrastructure, application 1, application 2, and then we symlink the Vagrant file and another bit of config into that greater folder, so that when you type Vagrant up, the folder that you've done that from contains the application and the infrastructure Git checkouts, but you can still version the config for Vagrant within the infrastructure checkout. I can give you a demo of that as well if you like. Anyone else?
How do you keep track of the different Vagrant file syntax changes between the versions? Changing quite frequently.
Yeah, so how do we keep track of version changes in the Vagrant file? Actually, the changes are less frequent now, like as of config version 2, which was about a year and a half ago, I think. They don't change that often. What we do, because we have tens of customers who are doing things with Vagrant, we have built a standard Vagrant file that can work on Windows and on Linux and on the Mac, which will read in a YAML file called boxes.yaml, which hides lots of the hairy detail away in another class. So what we're actually providing to customers is, here are some defaults in a YAML file, here's an array of box names and sizes and what have you. So if the implementation changes, then we can do that in our helper scripts, our helper class, and we can put version variation in there if necessary. But since we've done that, which was about 12 months ago, the config hasn't really changed that much in terms of syntax. The main benefit is that it means that we can abstract the differences between the VMware provider and the VirtualBox provider, which we support both of. And in theory, the Hyper-V provider as well, we don't do anything with that. But it's just Ruby, so you can do Ruby things with it, mostly. Anyone else? Yeah, so we try and use Hira for that for the most part. So our standard manifest set has a load of core services like an LDAP server and mcollective location and all that kind of stuff. And what we actually have is a hierarchy to say enable or disable the core services. Then we put that in the environment specific hierarchy file to turn that off. So yeah, it's that example is a little contrived, but the use of facts to do conditional things is reasonable compared to using things like host names, which is less so. Anyone else really see here? Can you see anyone have still? Cool. Right, I'm done then. Thank you very much.